Okay, we're going to take this function and find the local maximum and minimum, or minimums, of the function, which is x plus 2 cosine of x on the interval 0 to 2 pi. So that'll be our starting point. Let's go ahead and do that by first finding the derivative and setting it equal to 0. So the derivative is going to be 1 minus 2 sine of x. And I'm going to set that equal to 0, which means that negative 2 sine of x equals negative 1. Sine of x equals 1/2. So you should know that sine of x equals 1/2 when x equals pi over 6. And when x equals, let's see, 5 pi over 6. So it's just a matter of finding out which one is my local min and which one is my local max. Okay, so let's go ahead. I'm going to rewrite this. I've got a point. And the first one we said was pi over 6. And that's a point where the derivative goes to 0. And 5 pi over 6, where the derivative goes to 0. So what I'm going to do next is take the second derivative. And this is going to give me negative 2 cosine of x. I'm sorry, getting ahead of myself. And I'm going to plug in pi over 6. Well, when you plug in pi over 6, you get negative 2 cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2. 2's drop. All I'm interested in, it's negative. My second derivative is negative at this point, which means the function is concave down at this point, which means this point is a local maximum. Now I'm going to plug in 5 pi over 6 into the second derivative. And my second derivative is negative 2 times cosine. And 5 pi over 6 has a cosine of negative square root of 3 over 2. So here the 2's drop out, and a negative times a negative is positive. So my second derivative is positive. Positive things make you smile, which means I'm concave up at this point, making it a local min. Now, if it's a local max, that means I am increasing as I approach it, decreasing when I pass it. Over here, I'm decreasing clearly as I approach it, and increasing when I pass it. So not only can I tell you that where my local minimum and maximums are located, I can also now tell you when the function is increasing and decreasing.